So we mentioned that for a switch, it's possible for us to have maybe two different VLANs on the same switch. So by moving some of the ports into different VLANs, we can be able to separate two networks on the same device. But we said the challenge would then be the fact that it's not possible for people in maybe this VLAN called VLAN 10 to talk to people in this VLAN, maybe VLAN 20. The reason is this: you cannot talk to someone who is not in your network. So for us to be able to talk to them, we need to have
A router.
a router, yes. And we mentioned that there are various ways of handling it. So the first way was the legacy approach, where or the traditional approach, where you have maybe a router somewhere, and you have one port connected to this one. Maybe if this is say 10.0.0.1, and maybe you have in this 10.0.0.100, and you have another one connected here, it should be 20.0.0.100,
100.
and maybe 20.0.0.1, if you remember.
Yeah.
But the challenge here is this: assuming we have multiple VLANs, assuming we have a switch that has maybe two, something like this, and maybe another one. Maybe we have a lot. 1 second, let me try to turn on my. Yeah, so maybe we have a lot, yeah?
Yeah.
We have a lot of VLANs. So the first one is this. The second one is this. The third one is this. The final one is this. So we have 4 VLANs, yeah?
Yeah.
So maybe we can name it VLAN 10, VLAN 20, VLAN 30, and VLAN 40. Now, going by the first approach, which is this side, it means we need a router. Yeah, it means we need a router, and technically it means that we need 1, 2, 3, 4 links, true or false.
Yeah. True.
If this is 10.0.0.1, this is maybe 10.100. This is 20.1. This is 20.100. Yeah.
Yeah.
Maybe this is 30.1. Maybe 30.100. This is 40.1. This is 40.100. What does it tell us? It's telling us that for each VLAN we have on the switch, we need at least one port on the switch for that VLAN to be connected to one port on the router. You get the idea?
Yeah.
Even though it works and it's possible, we're saying that we're wasting ports on our switch, and at the same time, we're wasting ports on our router.
Yeah.
Does it make sense?
Yeah. Yeah.
So we would want to have a situation where we can do something different. So rather than having that, we can do this. We can do this. You can maybe connect just one port. It doesn't matter which port. So let's assume one port, but it's not really in any network. Yes, one of the ports. We connect it to a router. These ports are the ones connected to the PC are called access ports, if you remember. So we connect one port, we call it a trunk port. And from that trunk port, assuming this is F0/0, you create what we call a sub interface. This is what it means. I think we've done this before. Assuming this is that link, this link. A sub interface means that assuming this is F0/0, we want to find a way to partition it. Yeah. So maybe this side is for one VLAN. This side is for another VLAN. This side is for another VLAN. And this side is also for another VLAN. Does it make sense? So technically, just this interface, we're trying to divide it into sub-interface. So you could say maybe F0/0.10. Anytime you see a dot and a number, it's just creating a sub-interface. It means that you're trying to partition it. Then we can also create F0/0 maybe .20, maybe F0/0.30, F0/0.40. This dot, the number here, it can be any number. But the reason why we decide to do something like .10, .20 is that it makes it easy for whoever is doing it, so that we know that .10 is for VLAN 10, .20 is for VLAN 20, .30 for VLAN 30, 40. Just so you have a very proper naming convention. That's why we decided to do maybe .10, .20. But you can use any number. But it makes it easy. Does it make sense? So that if you are assigning a particular sub interface, so these are sub interfaces. You assign a particular sub interface to a particular VLAN, it will be easy. Are we clear?
Yeah.
So this is the so here we got here the last time. So this is the legacy approach, where you have, depending on the number of VLANs, you have the same number of links to connect to the default gateway. But we're saying that one is reducing how many ports we have. So we can do the second approach using just one of it, but we'll do a sub interface. Can you see here? So when you just do interface 0/0.10, it goes into a sub interface, and then you put the IP address there. So technically, you don't have to put any IP address on the main interface. You just have to do no shutdown. Just to say I'm opening this port, and then you do interface F0/0.10. If you don't do no shutdown, you'll not be able to use it. Is that okay? So here you can see that on the switch has some ports which are moved to VLAN 10. Some of them are moved to VLAN 20. I am sure you know how to do this one.
Yeah.
Is that okay?
Yeah.
The reason why they're using range here is that if you're doing more than one interface, but the commands are the same, you can use interface range, and then you put F0/1 up to the number you want to do. Is that okay?
Okay.
Yeah, this is 3 and 4. Now, on the other side of the switch, this is the interface connected to the router. Is that okay? On the switch, the interface connected to the router. So basically, this link, it's not going to be an access port. It's going to be a trunk port, because it's carrying VLAN information. So you just have to do what is it? Switch port mode trunk. This command on this kind of devices that we're going to be using, you don't need to type this command, because there are at least two main types of trunking protocols. We have .1Q and ISL. ISL is no more used. It was created by Cisco, but we're using .1Q. But most Cisco devices are already configured. If you set it to trunking, it will automatically have .1Q. So you don't have to do the second command.
Okay.
All right. Now on the router, you just have to do no shutdown, like I mentioned, just so that you open the interface. Then once you open the interface, just like saying I've opened the tab, now you have to create a sub interface. That's the only thing you do on the interface. You open it and that's it. Then you create a sub interface, maybe F0/0.10. Then you say, and this part on the router, you have to say encapsulation.1Q. And then you say, I want to use this particular one as a trunk, but I want to use it for VLAN 10. Does it make sense? So the exact VLAN number, and then you can then put the IP address for the default gateway for that particular VLAN there as well. So IP address and then the subnet mask. You do same for the other one, and you'll be able to do the trunking. So let's just do a quick one. And let's see. Can you still see my screen? Are you seeing the packet tracer?
Yeah, I can see the packet tracer.
Okay, so I'm going to pick a switch here. And then I'm going to pick at least, let's just do only 2 pieces because we don't want to be stuck today. We just want to finish fast. Yeah. Now F0/1 is going to be for VLAN 10/2 is going to be for VLAN 20. So let me first do that. So interface F0/1, the switch port mode access, switch port access VLAN 10. Okay. Then we do interface F0/2, switch port mode access and switch port access VLAN 20. Yeah. Now I'm going to put the IP addresses. I'm going to say 10.0.0.1, 255.2, sorry, 255.0.0.0. Yeah. And then the subnet mask 10, sorry, the before gateway .100. Then I'll do this one. 20.1, 20.100. Yeah. Now I need a router. So I'm going to connect this. And again, I prefer to do 10.0.0.1 here. 20.0.0.1 here. And for the sub interface, I'll say interface F0/0.10. I'll give it 10.0.0.100. And interface F0/0. Which one would that be?
.20.
.20. So what would we give it? 20.0.0.100. Is it making sense up to this point?
Yes.
Okay, so now I go on the router. And then on my router, don't forget that you have to set this to trunk. Do you remember? So interface, I mean the switch, this interface is a trunk link, yeah? F0/3, saying switch port mode trunk. Yeah. And if you try to do switch ports encapsulation, it will tell you that that command does not exist.
Okay.
Do you get it? So if you remember this command I was telling you about,
encapsulation.
What is it? Switch port trunk. Okay, what is it? It doesn't exist anyway. Oh, what is it? Switch port trunk encapsulation. You see, it doesn't exist. Have you seen that?
Yeah.
Okay, so basically, like I said to you, it's already existing. It's already, when you set it to trunk, it's already .1Q. So that's it for the switch. Now let's go back to our router. So this router, which interface is that?
F0/1.
No, this interface.
Okay, F0/0.
Okay, so we do a no shut. There's no F0/1 here. We're doing /0. Now we've turned the interface on. That's all we need to do. The next thing is for us to do interface F0/0.10. And it says we've created a sub interface. Look at this side.
Okay.
Can you see that?
Yeah, I can see.
So we can say most of the time I like to give descriptions, but it's up to you, description. Then you say default. You can do that, but it's not compulsory. Default gateway. It's a VLAN 1, a VLAN 10. Is that okay? You don't have to do this. It's just because when you do show run, you want to know which particular interfaces for which particular VLAN. Is that okay? But it's not
Okay.
compulsory. I'm just doing it there just so that you know. 10.0.0.100. Let's see. See, and the subnet mask. So 255.0.0.0. Yeah. By saying configuring IP routing on a subnet is allowed only when you set your .1Q. Do you get it? So you have to set it to .1Q. So you say, and before we can do that command, you have to do encapsulation .1Q, and then the VLAN number. What's the VLAN number?
10.
So we say VLAN 10. Oh, sorry. So we don't have to say VLAN. We just say 10. Is that okay? Then you now put the IP address. So you have to decide which VLAN that particular sub interface will be before you can put the IP address. Is that okay?
Okay.
Does it make sense?
Yeah.
Now you do the same for the other one. So we say F0/0.20, and then we'll say encapsulation. Do you want us to give her a description?
Yes, please. Yes.
Description, and we'll say default gateway VLAN 20. Yeah, and then we'll do encapsulation .1Q 20. Yeah, and I'll say IP address 20.0.0.100.255.0.0.0, and that's it. So now, if we are trying to ping, I prefer that we first do IP config, and it's having an IP address and a default gateway. Let's try and ping our default gateway, 10.0.0.100. It's pinging, yeah?
It's pinging.
Let's see whether we can ping the default gateway for the next network, which is 20.100. It's pinging.
It's pinging.
It means we're making progress. Let's see if we can ping 20.1. It's pinging, yeah?
It's pinging.
Yeah. So do you get the idea? Sub interface. And that's the amazing thing. Again, we don't need to do any routing because they are all connected to the same router. If you remember, the two networks are connected on the same router, so we don't do routing. If you remember when we're learning routing, what we said, you only do routing if this router cannot find that particular network or is not directly connected to it. Any question up to this point?
No. This one is clear because I can see that instead of wasting ports on the switch and the router, this one is just straight.
Yeah, so the sub interface one, or we call it router on a stick, it's a good one. And there is the downside. I mentioned the downside. If you remember what I said about the downside yesterday, I mentioned that there's a downside to this one. Do you remember the disadvantage of using this one?
No.
It's like you have a big pipe and you're reducing how much traffic you can send in each part. So it reduces the bandwidth because you have to. It's like you having it's not, the port is not for one network, so it's not sending. If it's 10 and you divide it into 2, means it's sending 5. Does it make sense?
Okay, yeah, it's not using the maximum capacity.
Yes, that's the downside to sub interface. But then it's the good thing is the fact that it's reducing how much ports you're wasting. So maybe for some reasons you have a network that has big bandwidth for the link, then that's fine. You can divide it. So otherwise, so it's again, every scenario will be different depending on what you're trying to achieve. Does it make sense?
Yeah.
So we have one more that you would have to look at, but then we'll finish it up maybe tomorrow, just a few minutes. It will not take too much time, and then we'll finish with VLANs, and then we move on to something else.
Okay.
Are we making progress?
Yeah, we're making progress. I'm making progress, big one.